Okay, what up YouTube? This is part 3 of my Christmas RGB LED project, where I'm making a big 4x3 Jesus Christ is Lord sign for my holiday display this year. And I'm actually going to narrate this part of the video live because it's the electronics part, which is probably my most favorite part of the whole project, doing an electronics project. And I have all the LEDs inserted into the sign just like you saw in part 2, and I want to go ahead and put together the electronics part, so when I start soldering up all the joints on the actual sign, I can test it as I'm hook them up and test them as I'm soldering them together. So what I'm going to use for the controller is this knockoff Arduino. Got from Amazon for $10. It's a Mega 2560 Pro, and let me just show you what it looks like. Oh, a couple of little, don't want to lose all the headers that comes with, but yeah, it's just a little SMD AT Mega 2560 Arduino. And I got this because it's cheap, and like I said before, I'm using Arduino so I can use the fast LED library. Now, after doing a little more research into the topic, I noticed that a lot of people are using these Wi-Fi modules. They start with the EP, I forget what number they are, but I'm not going to do that this year because I want to get this up and running this year. But you know, in the future I might switch over to using, you know, venture out into using different stuff than I'm familiar with. Even though I'm actually not totally familiar with Arduino, I have done Arduino projects like 7 to 10 years ago. Mostly I just program my own C programs in AVR GCC or in AVRC on regular 18 mega microcontrollers. Anyway, so yeah, this is going to be the brains of this project. And my plan is that I'm going to install everything in a Tupperware container. Now, that's just to keep the project cheap, and for being outside seasonally, a Tupperware container will be weatherproof enough for the project. Usually I do, when I try to do projects, I try to do it electrically right, but yeah, I'm just going to use the Tupperware container. So I got to get a Tupperware container the right size. I don't have the power supplies here, but I'm using two 30 amp power supplies because and I needed 2 of them because the project was over 30 amps, and that was the cheapest way to do the project, was to have 2 separate 30 amp power supplies. 5 volts are the LEDs. So so I have my Arduino here. I went and I bought this fuse kit. I am going to try to properly fuse all the power strands, power legs, and I'm doing that because the fact that this sign is outside and there could be water intrusion, and with water intrusion you would have shorts, so I want to make sure I properly fuse everything. I also bought these terminal strips to try to make power distribution a little neater, and I bought these PCB screw terminals to make things a little neater. I bought the cheapest 5 volt fans I could find off of Amazon, and as you can see, they're real small. But the idea is I just want to at least have one fan, even though it's small, to circulate the air in the Tupperware container, because I'm sure these power supplies are going to get pretty toasty. And then I just had had this laying around when Radio Shack went out of business. These went on sale for $1 each, so I bought a whole bunch of them. I bought perforated, and I also bought solid copper boards to make circuit boards. But the one thing I noticed, and I think it's because I'm using these, I'm keeping these outside in my shed here. I'm in my shed, that's where my electronics bench is. It's a non-insulated shed, no AC in Florida. I tried to use this a couple months ago for a project, and every single solder pad fell off as I soldered it. So I think that's from the humidity messing with the whatever glue they use for the copper. But I think I'm going to be good in this case because really there's not a lot going on the circuit board. The circuit board's just to hold the microcontroller and to put in screw terminals to access the pins on the microcontroller. So pretty much the only thing on this board is going to be a microcontroller. I'm probably going to put some filter caps on it to get a nice 5-volt clean supply to the microcontroller, since the 5 volts is going to be shared with the actual power of the powering the LEDs. And the screw terminals are going to be on this board. So actually this board is probably way big and overkill for what is needed, but I have this board laying around and I'm just going to use it. Plus I think with the power supplies it'll be fine. Or maybe I'll even do something where I glue these terminal strips onto the sides of the PCB for power distribution. But we'll see how it goes. So, oh yeah, and I also, before I begin, I want to show you this little chart I made. I was keeping track of all the LEDs as I was inserting them, and then I was trying to figure out the best way to distribute the power to try to get each strand to be at 100 LEDs or less, and it got confusing, so I have a new one here. So this is how I'm going to daisy chain all the power to keep each power leg at 100 LEDs or less, because according to the manufacturer of the LEDs, you can only add 2 strands together because of the wire gauge used in the strands. So they want a max of, each strand was 50 LEDs, so they want a max of 100 LEDs per strand. So there's going to be 7 power legs coming off, and there's going to be 7 power legs coming off, and this is how they're going to be changed through the sign. They're not straight through because I was trying to efficiently distribute all the LEDs out, and that's what I came up with. So yeah, let's try to figure this out. So we're going to have the microcontroller. I think I'm going to go ahead and try to, since this board is so big, I'm going to have the 5-volt power distribution. I'm going to hot glue these terminal strips onto this PCB. Actually, I can screw them. There's holes for screwing them. So there's going to be 1, 2, 3, 4, 5, 6, 7. So I am going to have multiple power wires under each terminal, but that's no big deal. And I'm going to have one 3-block terminal strip for my 3 data lines. I did decide that instead of having one data line for the whole sign, to try to make the data output a little faster, I'm going to separate it into 3 lines. One of them is going to be Jesus, the other one's going to be Christ, and the third one is going to be is Lord. So that's what this little terminal strip is for, and the holes line up for that. And then I'm just going to have the little filter caps I'm going to put right on the PCB. That's going to be no big deal. Originally I was going to use one of these 2 for the 5-volt power into the board, but if I'm going to mount this straight to the PCB, I can just hardwire it in. So pretty much this is what all going to be on the board. So I had to decide how I'm going to do this. I kind of like that a little better. One's going to be positive, one will be negative. And then I can bring my 3 data lines in like this. Oh, we probably want this like this so the USB connects to the microcontroller without any interference. I think that would work the best. So basically, yeah, I'm gonna just mount everything up like that. Okay, so this is what I came up with. Not my proudest work, but it'll work. As you can see, the terminal strips are a little crooked, which is throwing my OCD off. But like I said, it'll work. So 5 volts and ground. So I'll bring the 5 volts in from the power supply here, ground in from the power supply here. And I'm probably gonna have to split these up because there'll be 2 power supplies coming in. I probably had to cut these. But underneath here, I have a little wire ground, and that ground's coming to feed the Arduino. And then I decided, since this is going to be outside, I decided to fuse the 5 volts to the Arduino. So I put a little 0.1 amp fuse in there. So 100 milliamps should be enough to power the Arduino. And then I just came in from the back side of the port, put it to the 5 volts. Got my 3 data lines coming into Arduino pins 2, 4, and 6, I believe. And I did decide to go ahead and put the 220 ohm resistor in, even though I don't think it's needed, on all 3 data lines. So the data lines will plug in here. All the strands of the LEDs will plug in here. I had a leftover, this was pulled from a quadcopter of mine, 470 microfarad capacitor, low ESR capacitor to help power the Arduino, and then I put a 0.1 decoupling capacitor in there. And I only put 1 strip in for the one side because I'm not using the other side. I can always 3D print a little spacer, but the board pretty much holds up by itself since the board's so light. If I wanted to, I can, these 2 holes right here, I can 3D print a little spacer. I'm not going to fill this up because it's not needed. But yeah, that's what I came up with. So now I'm going to go and plug in this Arduino, make sure it works. I'm going to try to upload a sample program where it's just going to alternate red, green, blue on all 3 data lines, so that as I'm hooking this up to the sign, I can, test to make sure everything works. Okay, I got a demo sketch uploaded to the Arduino, although I had trouble doing that because it kept on saying error compile error for Mega 2560, so I don't know what that's all about. But I was able to get a demo upload that moves a white LED down the strand. And I have it hooked up temporarily, 5 volts. Have it hooked up to the strand, and then have the data line hooked up. So we're ready for the smoke test, and like any good smoke test, you always do the smoke test on camera. So here we go. Let's see if it works. And it works. So I put 350 as the test. But yeah, okay. So I guess I'll try to upload more data to test out the board. Okay, this is smoke test number 2, I believe. So I went and I created another program, and I created a program that's more of a permanent test. As I'm wiring this up, I can permanently test the situation. And basically, I have all 3 data pins active, and as you can see, I put some labels on the board. So data pin 2 will be the Jesus strand, data pin 4 is the Christ strand, and then data pin 6 is the Is Lord. And actually, I have all of them within 40 LEDs. Like Is Lord is like 217, I believe Jesus is 227, and this is like 230 LEDs. And what I have it doing, if I have it programmed right, I'm kind of new to this fast LED library, it'll simultaneously output data on each of the strands. The first LED in the strand, it'll light it red, green, blue, and white. Then it'll jump to the next one and light it red, green, blue, and light. And I think that would be a good test. So right now I have it hooked up to data pin 4, and we'll see if it sequences through. And if that works, I'm going to switch it between the data pins 2, 4, and 6 to make sure that I'm having data outputted on all of them. So here we go. And as you can see, it's working. So I think this is a good test because it's not going to draw a lot of power, only having one LED on at a time. And since the LEDs are different strand lengths, I did put an if statement in there so that as it's going through Christ, which is the longest strand, when it gets to outside the index of the other strands, it isn't updating those. So what I'm going to do now is I'm going to go and switch it around. You see, now it'll keep on going. So we're going to try data pin 2. And then hit the reset button. So data pin 2 is happy. Then data pin 6 is happy. So yeah, that's good for now. As far as earlier when I had having problems uploading a sketch to the Mega, it said compile error for the Mega. The only thing I can think it is when I was doing some simple Google searching that they said that let me reset it. That they said that some of the fast LED versions are incompatible with different, like if you're using like a hue setting, which I was trying to use the color palette demo. So yeah, we'll just continue moving on. Okay, so I went to Walmart and I got this Tupperware container, but the thing about it is I originally measured it out to be like that, and then I would turn these terminals in like this, and then I was going to make my hole for all the wires to come in and out in between the power supply and this, but as you can see, it's not big enough, so I don't know how I messed up on my measuring like I did, unless they measure the measurements they give are on the outside and not on the inside. And I wanted to get one that had a locking lid, but the thing is they didn't have locking lid ones in the sizes that I was looking for. So what I'm going to end up doing is I'm going to end up mounting the control board on top of the power supplies like this. Now traditionally the thing that you would have to worry about is noise from the power supplies going into the data lines, but I don't think the data lines are that high precision, high frequency that I'll have to worry about noise from the power supplies. And then what I'm going to do is I'm going to 3D print special like a special opening to bring all the wires in, and then the 3D print's going to have the ability to tie wrap the wires to the 3D print, so then that way there's strain relief, so none of the wires that are in here are going to want to be drug out the bottom of the hole. And that's what I'm just basically going to do, is just have a hole in the bottom of this Tupperware container, so then that way as far as water tightness, as long as the hole's in the bottom, water's not going to get in. That's my theory, at least. Okay, I mounted the power supplies into the container just using 2 screws for each power supply. That should hold it just fine. Right now I'm currently 3D printing the little grommet or opening cover I'm making. And I think the best way to secure this, or the easiest way to secure this to the power supply, is to make my own 3D printed standoffs. So I gotta wait for the 3D printer to be available. But one thing I am going to do is I'm going to coat the Arduino in this silicone conformal coating that I used to use for my quadcopters. And I'm going to do that just because it might get damp inside the box or high humidity, and it'll keep things from getting corroded. Okay, so I've been working on the control box. I got this Rubbermaid container from Walmart. Couldn't get it the exact size I wanted, but this was close enough. I wanted to get a snapping lid, like ones that had like a seal lid that came up and snapped over the top, but I couldn't get one of those in a size close enough that I needed, so I ended up getting this one. The box is going to has an open bottom anyway, so I'll just take a zip tie and put it around the lid to make sure the lid never flies off. So yeah, I cut a hole in the bottom and I 3D printed this grommet, I guess you can say. And I have the fan. I have a little chamber for the fan, and then all my wires are going to come up through here. The fan doesn't really, it has a little bit of suction, but basically the fan is just to keep the air circulating just a little bit. It's better than nothing. Like I said, I tried to get the cheapest 5-volt fan I could find. I probably, in hindsight, should have just gotten a 120-volt fan. But anyway, you see the plan is I'm going to bring all the wires up through this bottom here. And I have these holes in the side. Originally, I was going to have slots, or I did have slots that was in the 3D print for the zip ties, but I was too close to my tolerances, so I just ended up drilling out holes. And as you can see, I'll just secure the wires to the sides there, so there's strain relief inside the box. Basically, 120 comes into both power supplies parallel, and then the outputs come up to the terminal blocks. The ground terminal block is continuous, so all the grounds are tied together. The 5 volts is split between the two power supplies. And so now I'm gonna, well, I need to secure this board to the power supplies. So what I ended up deciding to do was I 3D printed these little blocks, and as you can see, I have a slot in there to put a zip tie through. So I'm just going to zip tie these blocks to the grate here, and then I'm just going to take a little screw. So I'll have one of these in each corner, and I'll take a little screw and screw the power supply in. I mean, not the screw the control board in. Yeah, and that's pretty much it. And the control box is officially done. That probably wasn't, I probably could have taken more time and 3D printed a more custom mount to make it look better, but as far as functionality, that was the fastest idea that I had that I could turn out quick. And I have a 5th one underneath here, not secured to anything, just in case bottom pressure on the board. And then these mounting screws here are also supporting the board from the bottom, so there's really no flex on the control board. I thought I would end this video showing my Arduino code because I anticipate that might be a question someone will ask. Plus, this is like the weak part on my end of the project, is knowing how to use this fast LED library and actually programming animations. So that's probably something I'm going to need help with in the future. Also, my buddy John watches these videos, and he had a criticism that I wasn't actually showing how to actually do the project. And that is true. These videos are more to document me actually doing the project and try to get the conversation flowing, to give you ideas on how to do a project similar, or to give me ideas on how to continue forward on the project. But it is true that, as I've been doing this project and looking at other YouTube videos, a lot of people would do the same, where they don't actually show you actually how to do it. So I figured I'll have a separate video at some point, probably when I'm done with the project, showing exactly how you wire up everything, how you configure the fast LED library, and I'll have that in one specific video. But here's the Arduino code of what I'm going to use as I'm wiring up the sign. Basically, at the top here, you include the fast LED library. Oh yeah, and by the way, this code, I just took a modified a modified example of the fast LED library. I took that and I modified it for my needs. So you include the fast LED library, then you define your variables. So up here I'm defining the amount of LEDs in each of the strands, and like I said, I have 3 strands. I have the Jesus strand, I have the Christ strand, and I have the Is Lord strand. And then down here I define the Arduino data pin for each of the strands, which I'm defining 2, 4, and 6. And then right here you create your arrays, your data strand arrays of the data, and you do that. Their CRGB is the data type, and you define the array with the amount of LEDs in each strand. So that's what I did here. Then you have your setup. So on all these setups on the example libraries, they put like a 2-second delay. And then here's when you're actually defining the fast LED library. So it's fastled.addLEDs. So the first thing you do is you put in what LED type you're using. I'm using the WS2811. And then you define your data pins that you're using. So define each data pin. And you define the color, the order of the color. And this one is RGB, which I believe is correct, because that's why I'm having each LED flash the RGB and then white as a test. So that order will make it check that the data is correct. And then you attach that fast LED library to the data array, which is Jesus, and then you define the amount of LEDs in each strand. And that's your setup. So then you go through the loop. So for the loop, it's just indexing a for loop, and I'm using index as a variable, and it just adding 1 to index every time it runs through the for loop. And since Christ is the largest strand, it's using the amount of LEDs in Christ. So then here's where you actually set what each LED is going to do. So you have the strand, you have the strand array, and you have the index number of the current LED you're on. And then there's several ways that you can set colors, but one of the ways you can set a color is by just the fast LED has color values assigned to names. So as you can see here, I'm doing red. And then since the other 2 strands have less LEDs than the Christ strand does, I just have this little check so that if the index is above the amount of LEDs in each strand, it doesn't update the color. And then it's updating the other 2 strands here. Then every time you want to update the actual output of the Arduino, you do fastled.show, and then there's a little 100 millisecond delay, and then it does the same thing, but it changes the color to green. It updates the output, has a 100 millisecond delay, then it changes the color to blue, updates the output, has a 100 millisecond delay, then it changes the color, it updates the output, and then it has a 100 millisecond delay, and then it turns the LED off, which is black, just turns the LED off, and then that's the end of the for command. So then it goes back up to the top of the for command, increments the index variable, and then it runs through again. So that's the test code that I'm using for testing the sign as I'm wiring it up. And this is the end of the video. So part 4 will be me wiring up the sign, and you guys will actually start seeing the sign display color, which that was another question I get is when are we going to see the sign lit up? Well, in part 4 you'll see the sign lit up. So thanks for watching.